Hello, geometry students. This is Mr. Allen. Today we're going to continue to move through chapter 4. We only have one section to cover this week, and that is 4.4, using corresponding parts. Congruent triangles. Picture out of the way. Okay. Our objective here is to use triangle congruence and corresponding parts of congruent triangles to prove that parts of two triangles are congruent. It's a mouthful. So here's the big idea, and this is the only big idea for today. If two triangles are congruent, then all corresponding parts of the two triangles are congruent. So this is an if P then Q statement. So if two triangles are congruent, then all of their corresponding parts are congruent. Now the way, instead of having to write this out, you'll see me write the letter CPCTC. That stands for corresponding parts congruent triangles are congruent. CPCTC. So for example, I'm telling you that these two triangles here, I'm telling you that triangle ABC is congruent to triangle DEF. Then all of their corresponding parts are congruent as I have marked. So angle B is congruent to angle E, as you can see that they are marked, and you will also notice that they are in the same order. Segment DF is congruent to segment AC. All 6 pairs of corresponding parts, that's 3 angle pairs and 3 segment pairs. So let's look at an example here. So let's say that I tell you that triangle WVU is congruent to triangle GHI. So I have these two triangles drawn here, and you can look and see it. It looks like that those two triangles are exactly the same shape and the same size. Their orientation is a little bit off. So here's my question. What angle is congruent to angle W? Well, you could look at the picture and probably figure it out, but the easiest way is to look at the congruent statements of the two triangles. You can see that the letter W is the first letter in the first triangle and G is the first letter in the second triangle. So that means that angle G is the congruent angle. And this is all by CPCTC. Corresponding parts of congruent triangles are congruent. All right, let's look at a proof. So let's say that I know that angle KBC, that's this angle up here on the left, and angle ACB, that's this angle down here on the right, are, oops, that's incorrect, sorry. Angle KBC, that's this angle with one arc. Let me move my picture up again here. So KBC, that's the angle with just one arc, and angle ACB, those two angles are congruent. We also know that angle K and angle A are congruent. Those are the ones with the 2 arcs. We are supposed to prove that segment KB, we want to prove that this segment is congruent to segment AC. All right, so that's what we've got. That's the given information. We want to prove this. Okay, so what's the reason for the first step? Well, pretty much, which is typical for most of the proofs that we do in this class, the first step is given. We know that those angles are congruent. Step 2 says the reason is reflexive property. Oh, yeah. So that this segment here is congruent. So I'm going to say segment BC is congruent to segment BC. Now, the reason that that's important is because that segment actually is part of both triangles. So now, why are triangles KBC and triangle ACB congruent? Well, we've got an angle and an angle, another angle and another angle, and then 2 corresponding sides congruent. So I think that since the side is not included, this is not included, or I'll call it non-included. That's the non-included side. This is going to be AAS, which is one of the theorems we did last week. So now we know that the triangles are congruent. Now, what are we trying to prove? This is the big idea from today. In fact, I could have given you this particular problem last week if I was asking you to just prove the triangles are congruent. But here, I'm asking you to prove that segment KB, that's this segment here, is congruent to segment AC. So the last step, obviously, is whatever we're trying to prove. So segment KB is congruent to segment AC. And that's going to be by CPCTC. Corresponding parts of congruent triangles are congruent, and that completes the proof. So there's example 2. All right, now example 3, what I would encourage you to do is pause the video here and see if you can complete this proof yourself. I'm not going to do that, but I'm going to chat here for a second and then I'll start working on the proof. So I just did this last proof completely from beginning to end. I'd like you to try this one on your own, but you can check your answers after you unpause the video. So it's given that segment VB bisects both angle EVO and angle EBO. We want to prove that angle E is congruent to angle O. So you can see we've got 2 triangles there. All right, I'm going to go ahead and begin my proof. So step number 1 is given. It is given that ray VB bisects angle EVO. And now step 2 says that the answer for the reason for this is definition of angle bisector, and I can see down at step 4 that they've got angle 1 and angle 2 are congruent, so it must be angle 3 is congruent to angle 4. Sorry guys, it's kind of hard to write here. That's an angle 3 congruent. In fact, let me just fix that. That's not very good. Angle 3 is congruent to angle 4. Now, step 3 is also given, so it's this same thing. Now, notice in this one here, we did EVO, so now what we're going to do is we're going to say that EB, I'm not going to draw the segment symbol above it, bisects. Now we're going to put angle EBO. That's also given. So now we conclude that angle 1 is congruent to angle 2. That's going to be the exact same reason we had on step 2. So that's going to be the definition of angle bisector. Remember all the way back from chapter 1, an angle bisector divides a angle into 2 congruent angles. Step 5, segment BV is congruent to segment. Oh, we saw that on the last proof. That's reflexive. That's the reflexive property. It's technically the reflexive property of congruence. Step 6 says ASA, so that must be a triangle congruent to a triangle. So let's just be careful about how we write our letters here. So I'm going to say that triangle, I'm going to go BEV has to be congruent to. Now here's where we're going to be careful. Angle BEV, if we know that this angle is congruent to this angle, right? So now when I name the bottom triangle, I have to go in that same order. So it's going to be triangle BOV. So notice, since this angle is congruent to this angle, and angle 1 is congruent to angle 2, and this side's congruent to that side, we need to make sure all of our corresponding parts match up. And so finally, angle E is congruent to angle O. Well, that's going to be by CPCTC. That completes the proof. So notice what we're doing here. We are using corresponding parts of congruent triangles. All right, last slide here. I would like you to summarize your thoughts. In your own words, summarize the big idea of today's lesson. So just jot that down on a piece of paper and call it a day. Thank you very much for your attention.